Good morning, everyone. So today we're going to go ahead and finish those Chapter 3 notes. So the last section that we need to talk about is 3.4, which is the composition of transformations. So what a composition of transformations is when a transformation is applied to your preimage and then a second transformation is applied. So this would be like if you reflected an image and then you rotated it, or you translated it and then reflected it. So you're doing two different things. So now we're going to end up with prime and double prime coordinates. One example of a composition of transformations is a glide reflection. And what a glide reflection is a translation followed by a reflection. Okay, so the translation is happening first. That's the glide, and then we are reflecting after we have translated. So with these, we're going to have multiple sets of points. So for example 1, we are given a triangle with vertices at 1, 1, 2, 5, and 4, 2. So we have our PQR triangle here. And it says graph the triangle and its image after the indicated glide reflection. So I'm going to start by finding my prime coordinates. So the translation is happening first, and then the reflection is happening. So we have to take care of the translation first. Remember, with translations, we're looking at each individual coordinate. So for instance, we start at 1, 1 for P, and then that translation is affecting your x coordinate and your y coordinate. So my P prime ends up being 1 plus a negative 3, so negative 2. And 1 plus a negative 3 gives me negative 2. So my P prime is going to be at negative 2, negative 2. I do the same thing to my Q prime. So Q started at 2, 5. And we're applying that translation vector, which is still negative 3, because it's applying to all points, the same direction and the same distance. So 2 plus a negative 3 is going to give us a negative 1 coordinate for our Q prime. And 5 plus a negative 3 gives me 2 for my Y coordinate for my Q prime. We're also going to apply that to the R. So R started at 4, 2. That translation vector of negative 3. So we're taking 4 plus a negative 3 to give us 1, and 2 plus a negative 3 to give us negative 1. So we're going to go ahead and graph our prime coordinates. So I have a point at negative 2, negative 2. So here's my P prime. Q prime is at negative 1, positive 2. And R prime is at 1, negative 1. So all we've done is translated or moved our points, all the same distance, the same direction. So now we need to complete the reflection in order for this to be a glide reflection. So the rule when we reflected over y equals x was that our x and our y coordinates switch spots. So our coordinates become yx instead of xy. This makes my P double prime coordinate, because now I'm reflecting. It's the second thing I'm doing to those points. Negative 2, negative 2. So my P and my P prime look like they're going to have the same coordinate point. Q double prime. My x and y switch, so I get 2, negative 1. And my R double prime, my x and my y coordinates switch, making this negative 1, positive 1. So then I need to graph my P double prime coordinates. So P and P double prime are at the same spot. So I'm just going to put next to it P double prime so that I know it's both points. 2, -1 is going to be my R double prime. I'm sorry, my Q double prime. And R double prime is at -1, +1. So these points are going to overlap each other, and the reason why is because your Q and your R are so close to your line that you're reflecting over. And if you forget what line you're reflecting over, or you just want to check your work, you can always draw in that dashed line to know that that's what you're reflecting over. So the line y equals x is this line here, which explains why P didn't change at all from P prime to P double prime, is because they fell directly on that line. And as you can see, Q and R have a very similar distance from that line of reflection. So on a test or a quiz, I'm expecting you to list out the points for P, Q, and R prime, as well as the points for P, Q, and R double prime. And then you would be expected to graph all 3 graphs on that image. So there is a theorem that goes with this, and that's the composition of isometries. What the definition of a composition of isometries is it's the composition or the combination of 2 or more isometries. Isometries are like when we change our points, but it still stays congruent. So isometries are like the reflections, transformations, and rotations. So an isometry says that it changes locations, but it's still congruent. It still stays the same size and shape. So example number 2. This point we're being given a line segment instead of an entire image. So we're given the line segment CD. So C is at -7, +1. And D is at -3, +2. And we're being given 2 different composition of transformations that need to be performed to this line segment. So it says graph the line segment and its image after reflection. So that means the reflection needs to happen first in the x-axis, and then a rotation of 90 degrees about the origin. So we have to perform those in order that they are given to us, which means in this case, the reflection should happen first, and then we should be rotating 90 degrees. So I want you to go ahead and pause this video and try example number 2. So on example number 2, the first thing that we needed to do was a reflection in the x-axis. So the rule for reflecting in the x-axis, remember we do need to memorize these rules, is that our x-coordinate does not change and our y-coordinate is going to change its sign. So that means that C prime ends up being -7, -1. And your D prime end up being -3, -2. So we are directly reflecting over that x-axis. And this would be the segment for your prime coordinates. So this is my C prime and my D prime. Then we are rotating around the origin. So I don't need to do any translations or anything that. But the rule for rotating 90 degrees about the origin is that my x and my y switch and then that first coordinate is going to change signs. So the rule is negative y, x. This tells me that your C double prime coordinate should have ended up at positive 1, negative 7. And your D prime coordinate should end up at positive 2, negative 3. So I'm going to go ahead and graph those points. So 1, negative 7 is my C double prime, and 2, negative 3 is my D double prime. So our graphs should look like this. Example 3, this time we're looking at a triangle. So we're given the triangle ABC, and we're given those vertices of that. And then it says that we are going to graph its triangle after a rotation of 180 degrees. So the rotation is what is happening first. And then a translation along this vector. So our second transformation taking place here is the translation. Again, we're performing them in order, so we should be rotating and then translating. Okay, go ahead and pause this video and try example number 3. So on example number 3, I have to start by graphing those original coordinates. So A is at negative 2 or negative 6, negative 2. B is at negative 5, negative 5. And C is at negative 2, negative 1. We are rotating 180 degrees about the origin. So I know the rule for that is that my x and y are not going to switch places, but they are going to switch signs. That makes my A prime coordinates 6, 2. My B prime coordinates 5, 5. And my C prime coordinates 2, 1. We're going to go ahead and graph those. And then after we have graphed those, you guys should have translated along the vector negative 2, 4. So on all of our x's, we should be subtracting 2. So 6 plus a negative 2 gives me 4, 5 plus a negative 2 gives me 3, and 2 plus a negative 2 gives me 0. And for our y's, we should be adding 4. So 2 plus 4 gives me 6, 5 plus 4 gives me 9, and 1 plus 4 gives me 5. So our A double prime is at 4, 6. B double prime is at 3, 9. And our C double prime is at 0, 5. So these would be our final answers. So the next theorem is a reflection in parallel lines. So if I reflect once over a line and then I reflect again over a second parallel line, this would be the reflection over parallel line. So it says the composition of two reflections in parallel lines can be described by a translation. So if I looked at the image on the right, you'd see that K and L are my parallel lines in this circumstance. Okay, so K and L I know are parallel because they're perpendicular to this same line that's distinguishing the distance here. So I know that if I had reflected my original P over line K, what ends up happening is that your triangle changes directions in the way that it's laying. By reflecting it then over a second line that's parallel to K, what ends up happening is that your image changes its direction back to its original position, but now it's traveled twice the distance of where it originally started. Okay, so from like P to P prime, just as an example, if I reflected it once, and let's say that caused a distance of 2 inches. These were now 2 inches apart from one another, from point to point. And then I reflected it again from point to point. I've now doubled the distance because I've reflected it twice. So because I reflected it twice, that means that the distance between points is double what it would have been if I had just done it once. So when I double reflect, I'm translating. Something also happens if I double reflect over lines that are intersecting. Okay, so this was to specifically parallel lines. But if those lines intersect, then the composition of those two reflections ends up being a rotation. So in this case, if I went from A to A prime, and I reflected over that line, I am then rotating that image, or I've reflected it over, right? If I then reflected it over that second intersecting line there of L, what I've now done, because if this were an image that had, let's say we're a triangle, like in the last example, it would have changed direction to get to A prime, and then it would change back to its original direction by landing on A. So this is congruent or the same as a rotation. So if this had been 25 degrees, which causes your X here, let me just label this in a different spot. So if you caused a reflection here, and I know that these intersecting lines cause a 25-degree angle, so here I'm rotating it once, and then I'm reflecting once, and I reflect once more. I've doubled this measure since I'm going over that angle. So to get from A to A double prime, because you're reflecting twice, you're doubling whatever angle is formed by those intersecting lines. This would be a better example if it were an image like a triangle, because we know that triangles aren't all congruent to one another. Like these line segments, it doesn't change directions. Let's say that I was given that this was a 30-degree angle between your intersecting lines, and I had a triangle. So when I reflect it once, your triangle changes directions. And then when I reflect it again over that second intersecting line, your triangle changes direction back to its original position because of that double reflection, which is causing that angle to be doubled. Because I have to double it, go over the two lines in order to get it back to the correct position it needs to be in. So on example 4, we're just looking at the measurements that are being given to us, and we're trying to determine what it would be equivalent to. So it says if B were to reflect in line N and then line Q, describe the single transformation that would map B onto B prime. So using the two theorems that we just stated above, I want you guys to go ahead and pause the video and try example number 4. So on example number 4, what we're doing is we are looking at, if I reflected that B over, so if I reflected it, my B would end up here once I reflected over N, and then I'm reflecting again, and it ends up on the other side of Q. Based on the theorem that we just discussed, that means that this is equivalent to a translation. So I know that this is a translation. And I know that since I have doubled that distance, or I've gone over twice, we are taking that 3/8 and we are multiplying it by 2. Since we're reflecting twice, we're going twice the given distance. this would be the same as 6 over 8. And I know 6 over 8 simplifies to be 3 over 4. So I would say that this is translation of 3/4 inches. On this second one, I know that if I reflected over n, that my B coordinate is going to end up here. And then I reflect again over Q, and my line ends up here. My point B ends up there. So since these intersecting lines form a 25-degree angle, and I've reflected twice, I know that I should be taking that measurement twice. So this would be a rotation of 50 degrees. Questions like these do show up on the Chapter 3 quiz, so I would be sure that I'm aware of these two theorems. Okay, I know that you guys have asked to make it more clear what's going to show up and what isn't, and this is one of those things that will show up. Example 5, they are actually giving us the double prime coordinates. So they're giving us the end result. And it says the pre-image was rotated 90 degrees about the origin, and then it was reflected in the x-axis. So because they are giving us the final coordinates, we actually need to work this problem backwards. So these are our final coordinates, B double prime, C double prime, and D double prime. That means that the last thing that was done to them was reflection in the y-axis, so that, or x-axis. That means that's what I need to do first, and then I need to do the 90 degrees. So because they gave me the final result, I need to perform the operations backwards in comparison to the statement provided to us. So I want you guys to go ahead and pause this video and try example number 5. So on example number 5, they gave us -4, 4 for our B double prime. C double prime was at -2, 5. And D double prime is at 1, 2. Because they gave us those final coordinates, we're working the opposite of what's given to us. So we need to take care of that reflection in the y-axis first. So when they reflected in the y-axis, what they did was they took x negative y. So since that was what was performed, we need to perform that same thing so that we can get our y-coordinate back to how it should be. So I am taking my B double prime coordinate, and I am going to negate or change the sign on all of my y coordinates. So B prime is going to be at -4, -4. C prime is going to be at -2, -5. And D prime is going to be at 1, -2. So since all they did originally was change the sign on y, we can change the sign back on y to figure out where that coordinate should be. So my B prime is down here at -4, -4. C prime is at -2, -5. And my D prime was at 1, -2. So from these points, I need to figure out how to get back to my original. So it says that it was rotated 90 degrees about the origin to get where they are now. So if I were looking at the rule for a 90-degree rotation, we would have -yx. But this is what they did to move my points to where they currently are. So if this is what they performed to get them here, I need to perform the opposite signs in order to move them back to where they should be. So I'm going to take B. We're going to negate our x. So our x was -4, so this is going to become +4. And then my y is going to be a -4. So B is going to be at -4, +4. Our C, our x and y are going to switch, and our x coordinate is going to become positive. And our D, x and y switch, And our y coordinate, our new y coordinate is going to change signs. So I have a -2, -1. And this is our D. So even though our original image isn't very far off from our double prime image, you can see the difference there and how they got there by looking at those rules that we had typically used and working backwards. Tonight for homework, you do have bookwork because we have a quiz on this unit instead of a test. There is not a study guide for the quiz. Instead, you still have this homework to practice these concepts so that you're aware of this section of notes and that you are prepared for your Chapter 3 quiz next class. If you guys have any questions,